Hello, testing my audio. Hello, testing my audio. Looks like it works. Let me see. Closing that. So first thing I want to do is maybe to change the theme because I have installed a theme on my Visual Studio Code. So Visual VS 2026 change theme. So let's see how to change a theme. We go to Tools, Options, Environment, Visual Experience, Tools, Theme. Here we go. Okay, we should have. Here we go. VS Grover Darker. Okay. Seems like it works, but it doesn't look so promising. Let's try Groovebox Dark. Okay, that is better. Let's try something else. Let's try Dark Plus. What is that? I thought so. I think that's like in Visual Studio Code. Uh, let's see. Okay, I guess I'll just stick to VS Grover Dark. Okay. So basically today I wanted to implement an asset manager, and let's just go ahead and try that. So asset manager.h, I'll create a header file, add it to CMake. I'll make the code bigger so you can see better. But first of all, we're gonna do this pragma once. Okay. Then I'm going to create a class asset manager, just like that. Class asset manager. Now, an asset manager should be a singleton, right? That means that you are only allowed to have one instance at process running. Right, and to achieve something like that, we can stick to the usual scheme of doing such things, where you basically have an asset manager pointer, and it's usually a static stuff, so you gotta mark it static. And then here in the public, then you have to forbid constructing a set manager usually, as it is usual. And then in the public, what you expose is basically an asset manager pointer that, and we call it like something like get. Right, so you're allowed to get an instance of an asset manager. So that will be our code for doing such things. And now I think we're just going to create a CPP file. Right. So, but before doing that, we need to store textures. So for that, I will create a vector. For that, we will need a vector library. So creating a vector, asset manager, it's basically a vector of assets. Now, As an asset, we have textures, you have a lot of different stuff. And I saw some people creating an abstracted class for the asset, which they call iAsset, which you basically have to implement in order to be able to be handled by a set manager. So let's actually stick to that pattern and have an iAsset vector of those assets, of pointers to those assets, and I will call it something like assets. Right? So very simple till now. Now, this guy is going to be a virtual class. So it means it has some virtual stuff in here. So first of all, what I want to do, I want developer to force create a destructure, right? So we do this thing. Okay. Then what I want to do, I want to create a virtual function which will be called load. Man, I don't know. So, but what we will have is basically unload, which you are required to implement, and which is a void, right? So unloading an asset, this is basically how it's done. Okay. We've got the asset, we've got the vector of assets, and now I'm just going to straight up create CPP file. I'll call that CPP file asset manager.cpp, add it to CMake. So we include asset manager.h, and then we implement all of those functions. Okay. So we don't need to implement anything from here. We just have to implement this function, this, define this, and remove that. So first, getting an instance. So first of all, we want to be able to construct an asset manager. And I think in our case, what we want to do is basically initialize. So I copy this, and then we just initialize assets, which will be initialized by default. So I don't need to do this as far as I understand. And here, what we do, we just check if there is no instance, then we return, then the instance will be constructed, right? So new asset manager, and then we return that instance. Right, so that's the way of how we create a singleton. Then this guy has to be initialized, so we gotta do something like that. And here we go. So we've got the asset manager. Now, how do I see this? I basically see a usage of this class as something like this. So we've got this. Nope. 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 No. Okay, I will change the theme. Okay, great. So how are you supposed to to use an asset manager? So what I imagine myself is that you have an asset manager. So asset manager equals asset manager get. So we're getting an instance of the asset manager. And then inside, and then using this asset manager, you can load some of the textures by doing what? By doing asset manager load, and then you specify which asset, which type of asset you want to load. So for example, texture asset. And then here, all the parameters required to actually initialize this class. So this is basically how we want to go. And for that, we might want to create a texture, another structure, test structure, which will be called something like texture asset. And inside of this texture asset, so first of all, it extends the asset, and then how do you construct this? We might want to say something like you provide a string, a path to that texture, right? And then you're overriding the texture asset structure, which will basically not override it, but call the iAssets structure as well. So inside of the texture asset, the structure, we're not going to do anything special, so I've just marked it default. And then we might want, so we need to implement this. So override, and then we want to implement this unload function, which we'll need to override as well. So that's basically the way of implementing. Then there's a okay, constructor. Let's actually do this and then store the path as a member. Here we go. So we're storing it as a member. And let's implement additional function to actually print the path. So something like get path, which is const, and actually returns you const std string, I think. But let's stick to this. It just returns you mpath. And we might want to get constant reference to it just in case. So yeah, that's basically how it looks. So that means that in our asset manager, we want to be able to load something, and you can get a boolean for loading an asset. So load, and then here we do template type name asset, where you basically provide that asset and requires. So we can now implement say that this asset type should be implementing or extending iAsset. So, and for that, I think we need to do include concepts, and then we just say is base, no, is derived, no, derived, I think it's std, derived from, yes, asset, and then you say iAsset. I don't know if something like that will work. But then here you actually have to provide arguments. So, and somewhere in my entity class, I had this function to, yeah, here we go, to actually create those arguments. So we just do this. And then here we're moving all those arguments, right? Um, okay, let's actually Google it up. So what I want to Google, yeah, C++ concept is based off. So you can find that in the type trace, and there should be an example. Yeah. So I think that's a runtime thing, but there should be a concept derived as base. Checking if derived frame from template class with a known. Okay, if you want to check for specializations of A specifically, that isn't too difficult. That only binds to A. So yeah, right, but there was a concept. Check if type name extends class. Okay, maybe I understand concepts incorrect. Maybe there are for something else. Which checks whether a class can have different type of template parameters. So let's actually check out the concept header file. Here we go. So we have a concept is same. Let's search for derived. Here we go. So we have a concept derived from, which checks, you pass in the derived and then the class, the base class, and then it checks if derived class, if this base class is a base of this derived class, and then we check if we can convert this derived class to base class. So I think that's exactly what we need in here. Do we use that? We are actually using it. So I think I just use it incorrectly. Concept. It's since C++ 20. Okay, you have to do. So there is a concept which is something like that. But there was something with requires. Here we go. Okay. So asset. Okay, then let's do STT derived from, where you have to pass. Wait, requires asset equals to STT derived from. asset, I asset. Is that what we need to do? No, that is not that. So we're declaring a concept hashable which takes in some type, and it just equals to requires type A, and then we give out the requirement, I suppose. But isn't this, so let me check, derived from, it is a concept, so why can't I use it when you have this? So why can't I just use something like derived from, providing the asset and then the I asset, and then just do this? It is not a type name. You're right, because it's oh, do I have to remove it? And then I have to provide something like this? Oh wait, oh wait. I think I start to understand. So you create an asset, you have a type asset, then you have to check if that asset derived from the I asset, but why does it say that? Do I have to call this or what? So derived from base. Okay, I asset. Here we go. Is this the right syntax? I don't think so. Okay. It complains about the definition, but as this is template stuff, we're working with template here, so I'll just directly provide the definition in here right away. So args was referenced but not expanded. Okay, let's skip this part. So yeah, we just need somehow. So what am I doing wrong here? I understand that I need to use the concept derived from. Maybe it's because I'm using the wrong standard. Let me see. So yes, that's not that one. That's all the source. Here we go. So set property, we set the standard to 20 if the version is, and it is greater. So we're actually having the standard 20. Now the thing is that so there is a concept which is called derived. How do you use that concept? Oh wait a second. So I have to do something like asset. Okay. Okay. Load is not a template. Well, it is. Why? return true. So it still complains. It still complains. I don't know why. I don't know why it complains. So change signature. Okay, what you will do? What? What is that? No. Okay, we don't. Okay, we just don't accept it. Okay, cool. So we have this. Now I provide arguments. So type name args, and then I accept them arguments in here. I think this is how you do that. Okay. Okay. They need to be expanded. Here we go. So what do we do now? We just have to do m assets emplace. We emplace that type into our assets, and we create it using this arguments. So args, and I think you have to provide dots in here, and then return true. Is that how you do that? I think that is how you do that. Okay. Let me check out the entity. Yeah, that is exactly how you do that. But then, what is this check for? I mean, if you check everything at compile time, I mean, yeah, okay. So this guy, what does it return? Let me see. It returns an iterator. And if I go to iterator, so it's just a basic iterator. So if I do something like it, what can I do with no members available? So what are you? You're nothing. Okay. Let's just stick to this, right? So we have a set manager load function, which I will basically load an asset and push it right in here. Now, I don't think it will work because we're messing with with pointers. I'm sure at some place we have to put a pointer, but I just don't know where I have to do that. So let's just stick to this. So do we have to implement something? I don't think so. So now in my main, why am I doing extern seal? I'm not using SDL as you could have thought of. Okay, so we've got our first errors. First one says that, yeah, basically what you have to do, you have to first define this abstracted class and then only try to use it. So let's try to build and run. Okay, it runs at least. I don't need to fully run it, so I'll just close it. So suppose I will just return 0 and I will have my asset manager. So asset manager equals to, and then I need to include the asset manager.h. And then I'm just doing asset manager get, right? So I'm getting the asset manager. A non-static, okay. Of course, I forgot that this guy should be static. Does it have to change? No. Okay. So we've got the asset manager. Then all we do is basically do manager load. And then here comes the interesting part. I provide the texture asset. And then I open it and I provide the arguments this guy requires. And now I'm not getting those fancy helper stuff. I mean, how do you do that with employees? You just do class dot 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 volty. You're taking it. Okay, vol type. And then you're just getting the verb pointer, the data. So I'm only interested in this guy. std forward well type. Yeah, we just do this. Then we do that again. So yeah, it's basically the same. You don't have any possibility to describe that better, I suppose. So we'll just stick to this. So how do you create it? You have to provide a path. So let's provide some path here. Right. And then the asset manager has to uh, have a destructure, right? So we have to implement it. Let's actually go ahead and implement it. So just like that. This guy should be moved in here. And then what we do, we're basically going through the assets. So auto assets, m assets. And what we do, we just call unload function on that asset. That's basically the idea. Now this texture asset has to be implemented. So let me just grab it and remove some of the stuff here. Paste this. Paste this. Now, how do you construct that stuff? You just have to assign path, then the constructor, which equals to default, so we don't need to do that. Now unload function of that texture asset. And then what we do in here, we can just do something like, we could use a logger. So let me put basics logging .hpp, and then I can define something like logging, which will be asset, something like that. And then I'll just do a logger info. Then we provide the logging, so the source. And then we provide the log itself, where I can say unloading a texture asset with path equals to plus the path and closing stuff. Right, and then last but not least, we have to implement texture asset get path, and then we're good to go. Now in here, in my texture asset, I didn't actually have to implement this getter, so I can stick to this. Okay, let's actually see if it works. Let's see. So it's not building. That's already an issue. Oh, let me search for specifically error. Here we go. No matching overloaded function found. Yeah. So that's basically the issue. Let me stop. Let me see. So we do m assets in place. And then I provided this type. So I think we have to provide a pointer here. And then just let's see. But the good thing is that it complains at compile time. That's a cool stuff. Or is it? So error plays back the asset. Right. So what we have to do. That's an interesting part. So because vector in place pointer. Yes, so this is basically what I need. Don't use row pointers, do it like this. And as you can't copy construct, you must use and place back, although you can use pushback with std move. So let me see. So this one doesn't work, or as it appears that using vector and place back and new can leak if the vector needs and fails to reallocate memory. My recommended approach until C++14 introduces make unique is to use pushback like this or using make unique. Yeah, so it's basically not that good. So the question is, do I want to share this pointer? Do I want the unique pointer? And I think unique pointer doesn't really work in our case. So what I think we have to do, shaded pointer of that I asset. And let's see. Okay, it works. So then what we can do, we can emplace back, but what is the difference between emplace and emplace back? So let me then use emplace back. And then what I'm doing is basically putting in shaded pointer of an I asset by doing a new shaded, or do I have to do that? I actually have to do that. So let me stick to this. So std make shared I asset, and then you have to provide in. So let me actually do asset. So then you have to provide in those arguments. Just like that. So we place back, we do make shared, which doesn't really make sense, right? I think that's, yes, as far as I know, and place back new object can still leak if vector fails to allocate memory for the new. To use and place back with make unique. In practice, no, but it's a little bit misusing the API, as in placebreak is meant to be for in-place construction, yeah. So we can't really construct in place because it would have to implement it using new keyword, and I don't think it is doing that. And plates wanted back. Okay, so let me just push it back. Push back std shared pointer asset, and then std make shared, and then all this. So let me try to build F7. Here we go. We've got, okay, we need to include memory, unexpected token following. I don't really understand where. So 42 following simple type specifier. Missing one of. Okay, I think we're missing. So pushback, here it is. It's for pushing. And then std make share it. And then providing in those arguments. Yeah. But let's also try to make it simple for now and just have an asset pointer like this. And then what you basically do is push back that pointer by creating a new, by allocating on the heap. So then you do forward, args, just like that. Let me try to build it. So here we go. Unexpected token following simple type specifier. Wait a freaking second. We don't need to do. It's not a template function. Oh my god, what am I doing? What am I even doing this day? Okay, it links. It seems to be working, and if I try to run this, we just don't see anything. Which I suppose is fine, but it's actually not, I suppose, because when destructing, we should actually. So let me do logger info logging destroying assets, and in my main, let me grab it inside of the scope. So maybe then it will work. Let's see. So asset manager get set manager load. So let me add some logging here. So logger info, and I think this is something that we need to include in here. So include basics logging. Okay, cool. Logger info. And then let's do asset manager, loading an asset. Load it, and then plus std2 string m asset size plus assets in total, just like that. And inside of my texture asset, inside of my constructor, I actually want to do another log. Loading a texture asset and path equals to, and then empath, and then plus this. So let's run this and see how it will work. Loading an asset, loading a texture asset at path, and then loaded one assets in total. So I suppose this structure hasn't been called at all. Yes. Why though? Why this structure hasn't been called? C++ the structure not called. Oh yeah, right. We have to delete it. Oh my god. Or you use a smart pointer. Okay. So maybe inside of my asset manager, what I have to do is to store unique pointer to my asset manager. And then inside of my asset thing, yeah, so here we should do unique pointer of asset manager. Okay, this works. Let me see how it will work. Okay, we're missing, and we definitely miss some stuff here because here we go. So std make unique. Asset manager. All right. And then here you might want to do, so you're not sharing a thing. So let's actually do shared pointer, and then in here we do shared pointer. Okay, and then here we do std shared pointer set manager. Get. Okay, and then you create it using make shared, and then you return it. That's cool. And now it should be called. Now the structure should be called. Let's see. So cannot access. Wait. So the first issue was no matching overload function. Construct in place. Cannot access private manager member declared in mm-hmm. Mm-hmm. That's basically it is. So we have some issues here. Set M is undefined. Let me close this and open it up again. So we don't see any issues. Let's try to build it again. So it complains about this line. If there is no instance, then the instance will be a new shared pointer, which is right. Which is actually right. So a set manager, the structure. So let me maybe include initializing set manager. Manager and its assets. Hmm. So I suppose someone else should be taking care of an asset manager, and we can't just rely on shared pointer. So which could make sense, but I don't think so. So let me just do std shared pointer asset manager. Maybe this function should return a shaded pointer. I don't know though.